Welcome to the first in this series of lessons for A-level computer science. In this lesson, we're going to learn about a very important concept in programming, which is the use of abstraction. In this lesson, we'll look at the nature of abstraction and why we need to use abstraction when we're creating computer programs. We'll compare an abstract model with reality and think about what factors we have to take into account when we create an abstract model. So, what is abstraction? When we create an abstract model of a real-world system, we remove all the unnecessary details and we're left with a simple structure. We often use symbols and conventions so that we can render the details as simply as possible. And frequently, our model will generalize from many examples to pick out the factors which many different systems have in common. Computer scientists have to use abstraction when they're creating software systems to model reality. That's because reality is incredibly complex. If you just look around the room where you're seated now, there are so many different details and things happening that if you were to build a computer model of it, it would take you years to accurately render all the details, and you'd need some sort of enormous supercomputer to run your program. So every time when we're modeling systems, we always have to simplify them. So here's an activity that we did in an earlier lesson, if you did the ones in the other in Python pages, where we took the dimensions of a room and created a simplified model to find the wall area of the room. And we lost all the details in the room apart from height, length and depth. Here's another example. If you're flying over a city, you might notice that the pathways and the tramways are extremely wiggly and uneven. But when we draw a map, let's say of the underground railway lines, they're done in a very simplified and stylized way. A lot of the detail has been lost and standard symbols are used. And here's a third example. A scientist might be modelling the water cycle of evaporation and rainfall, and they'll lose a lot of the details of a complex ecosystem to simplify it into a physical model of water transfer. In all of these examples, the abstraction allows the user to focus on the key points that are of interest to them and see the overall structure at a glance. It also lets them reuse previous solutions and models that they've built up. For example, if I've created a tube map for one city, I could easily use the same system to create a tube map for a different city. And perhaps most importantly, it's less work to make a model that contains only the points that are of interest to you. There are some risks, of course, and I'm just going to quickly mention them. What if we left out the wrong details? What if our bias or our preconceptions caused us to focus on the wrong thing? So when we're building an abstract model, the key thing is to know what the context or purpose of our abstraction is. We then leave in the details that are relevant to our purpose, and we also think about what our current problem has in common with previous problems that we have tackled. So it's important to make revision notes so that when you come back to these ideas later, you'll easily be able to check what you've learned and make sure that you remember it. So you should have notes in your book on the difference between abstraction and reality, the reasons for using abstraction, and how to make a good abstraction. This is a really common topic in the exam, so it's important that you're ready to answer questions on it. For the most part, you can answer with these simple details. The difference between an abstraction and reality is that many of the details are left out. The reason for using abstraction is that it is much less work and processing power to run an abstract model. And how to make a good abstraction is to think carefully about the purpose of the abstraction and to select details that are relevant to that purpose. And I'm going to leave you with a programming activity. Think of a fish pond. I've just I've got a photo of an example here. Enter the dimensions, so those would be 3 values entered by the user. Calculate the volume of water in the pond and the surface area of the pond. Let's say that evaporation per day is 0.6 of a centimetre multiplied by the surface area. How much water is lost each day to evaporation? How much water is gained by rain? And we could have the rain as the surface area multiplied by the millimetres of rain that fall that day. My picture's actually got a bridge which would protect some of the surface from rain, so if you wanted to take that into account, that's fine. And then you could calculate how much water would be lost, and that would tell the person who owns the pond how much water they've got to pour into the pond through the pipe that you can see on the left. So it's to get this right, there are only 2 or 3 crucial factors that you need to calculate and then present it in a form which is useful. So this is my first programming challenge to you, and I'll look forward to seeing your results. Bye for now.